Okay, this podcast will be for lesson 4 in your workbook, which is on page 423. When you're going and doing this lesson with me, I want you to have 2 worksheets printed out for this. So we're going to be working through this workbook, but I'm also going to be flipping back and forth between the workbook, and you're going to print out this domain and range worksheets, which has some questions on it. And then you're going to have a domain and range worksheet at the end that you're going to do for homework. So you should have sort of 3 things: the workbook, the worksheet, and then a handout. One thing I want to sort of just talk about quickly before we start domain and range. So this is a concept in math. It's probably one of the most important concepts in Math 10C, and it continues into Math 20-1, 30-1, Calculus, and University. So it's an incredibly important concept, and I always sort of like to forewarn students that it's a bizarre that you have to know. So the 3 different types of the domain and range for the following set of ordered pairs. Remember, you guys, ordered pairs are x comma y, and I just told you that all of your x values belong to your domain and all of the y values belong to the range. So if I said list the domain of all of these ordered pairs, how we would do that is you're going to tell me you're doing the domain by capital D and then colon, and then we do a fancy bracket. Okay, when we list the domain, we are listing the x values. So these are all of my x values, and you list them by convention in order from the smallest x value to the biggest. So the smallest x value would be -3, followed by 0, 1, 3, and 5. And then I end my domain with another fancy bracket. My range is the y values. So I start with a fancy bracket and I'm going to end with a fancy bracket. 2, 5, 8, 9, and 2. So we, again, by convention, go from the smallest y value to the biggest. If we have a repeat, like 2 and 2, you only list it once. So my smallest range, y value is 2, then 5, 8, and 9. So take a minute to see if you could do B. And remember that domain is your x values, range is your y values. List them from smallest to biggest. If there's repeats, you only list them once. So let's see if you got it right. Domain. Smallest x value is -8, followed by -3, followed by 0, 2, and 3. That would be my domain. My range would be my y values: 3, 3, 3, 9, and 3. Okay, 3, 9. There's my range. Let's do class example 2, and we're only going to do class example 2A, so we're only dealing with discrete data. So if I said, okay, well, now these ordered pairs are actually graphed on a grid, which is totally fine. If I said, well, what would the domain be? The domain are all of your x values. So what is that x coordinate? That x coordinate is -4. This x coordinate is -3. This guy is -2. This guy would be -1. That guy's at 0. This x value is 1, 2, 3, and 4. -1, 0, 1, 2, and then I'll put the 3 and 4 in. 3 and 4. Okay, doing your range, erase any of the markups that you have and say, okay, now I need to focus on each ordered pair. What were the y values from the smallest to the biggest? So the y values, this y value, if I said, what's that corresponding y value? You'd say, well, that's 0. And what's this corresponding y value? That's also 0. We only need to list the 0 once. The y values on these two coordinates are both at 1. The y values on both of these are at 2, 3, 4. That would be your y values. That would be your range. Flip your page and let's do C. Okay, so let's do C. If I said, what's the domain and range from this arrow diagram? Well, you know that domain is your x's and range is your y's. So if I said, well, what's your domain? It would be all of your x values, 1, 2, and 3. What is your range? Well, what are the corresponding y values? 2 and 6. Okay? On the handout, so not the actual worksheet, but on the handout, I want you to do question 5. So question 5, if I said, okay, do your domain and range for this, so practice what we just did on here. So you could pause this, and then what I want you to do is pause it and then see if your answers match with mine. Okay, so domain are the x values. So that x value is at -3, -2. This x value is at 1. That x value is at 2. And that guy is 5. That would be my domain. My range, I'm going to erase my markups, and my range is all my y values for my smallest y value, which would be this guy here at -5. This y value is 0. This y value is 1. This y value is 1, so I'm not going to list that twice. And that y value is 4. Um, from there, I want you to go back to your workbook and I want you to do the homework questions that I'm going to assign for discrete values. So the homework questions, I want you to do all of number 1 and number 2A. So for number 1, it wants you to list the domain and range for A and B. So remember that domain is your x's, range is all of your y's. So these would be your domain, and you list them from smallest to biggest. And range, these would be your y values. List it from smallest to biggest. Don't do repeats. If you were to do this guy, the domain of this are your x values, 0, 2, 4, and 6. That would be your domain. Your range for this question would be 3, 4, 5, 3. So 3, 4, 5. I don't need to do that 3 twice, and that would be your range. Remember for arrow diagrams, those are your x's, those are your y's. So this would be your domain, and that would be your range. And just write it in a line with commas separating each value and your fancy brackets. Okay, when you're done that, you could pause it, finish it, and then we're going to do continuous data for domain. Okay, so for continuous data, we're going to start with question B here. And probably what I'll do is once I finish this, I'll pause the video again, assign you some work, and then I'll do this podcast in 2 different parts. Okay, so for example B, have to do the domain and range of this. Now this is a graph, and I need to know what is the domain or what are all of my x values on this graph. What you need to ask yourself is you need to ask yourself, what is the biggest and smallest x value on this graph? So if I was to ask everybody, like if you were in class with me and I said, well, what's the biggest x value on this graph? Biggest x value is 5. What's the smallest x value? Actually, is it 5? 1, 2, 3. Sorry. The biggest x value is actually 4. And then if I said what's the smallest x value, it would be this value here, which is -4. So your graph, all of the values are between 4 and -4. So how we write that is we're going to do something called inequalities. And when you have a biggest and a smallest value, you always put the biggest on the right-hand side and the smallest on the left. X goes in the center, and then you draw your inequality signs. So these would be my inequality signs here. And how this is read is you start in the middle and you read the right-hand side first, and then you go to the left. So you would say x is less than or equal to 4, greater than or equal to -4. So what you're saying is on your graph, the x's are less than or equal to 4, bigger than or equal to -4. Now, how we write that in proper notation is when we're dealing with data that's not discrete. So when we're dealing with an actual graph, you're always going to write x is such that. So it's x bar, and how you read that is x is such that. And then you write your inequality sign here. So x in the center, and you put your biggest x on the right and your smallest x on the left. And then you're going to end it with comma, XER. So what XER means is you're telling the person that's reading this is that X belongs to the set of real numbers. That's what XER means. And what that means is X could be a decimal. So what does that mean? X could be a decimal. If on my graph I pick that value there, that X value is between 1 and 2, which is 1.5. So on my graph, I could pick any number from 4 to -4, or it could be any decimal. And that's how we would write that. Okay, let's look at range. So range is our y values. And you always start with your fancy bracket. Okay, now you're going to tell your reader that you're dealing with range. So instead of writing x is such that, you write y is such that. Then remember, we're going to do our inequality signs. But instead of having x in the center, because we're dealing with range, we're going to have y in the center. And then we're going to do comma, YER, because y could be a decimal. So now all I literally have to do is I have to figure out what's my biggest x value, or sorry, my biggest y value, and what's my smallest. My biggest y value goes on my right, and my smallest goes on my left. So if I said, okay, if you were in class and I said, you guys, what is the biggest y value you could see on this graph here? I would hope that you would say, Mrs. King, it's 4. What's your smallest y value? On the graph, it would be 0. So my biggest y value on this graph is 4. My smallest y value is 0. How I read this range is the following. Y is such that y is less than or equal to 4. So you're telling your person that y on your graph is less than the number 4, greater than or equal to 0. And your graph lies between, all the numbers on your graph are between 4 and 0. So a lot of information there, but let's look at this one. And this would have actually been an exam question, but we're going to do it together. And it'll also be a quiz question. So if I said, okay, what's the domain of this graph? Domain are your x values. X is such that. We need to figure out on our graph what our biggest and our smallest x value is, comma, x belongs to the set of real numbers. So my biggest x value is 4, and my smallest x value is -2. Does everybody see that? And remember that my inequality signs, you always put the biggest on the right and the smallest on the left. And how I read this is x is less than or equal to 4, x is greater than or equal to -2. So this oval, all of the x values are less than 4, but they're bigger than -2. So 4 goes there, -2 goes there. Range. y is such that, I'm going to end it with yer, fancy bracket. Okay, y goes in the center because we're dealing with range. What is your biggest and your smallest y value? So on your graph, that's your biggest y value at 1. That's your smallest y value at -3. Biggest goes on the right, smallest number goes on the left. What you're telling your reader is that on your graph, your y values are less than 1, but they're bigger than -3. Take out the handout, which was this guy here, and we're going to do a few on this handout. Number 4, we're not going to do it all. Let's do 7 and let's do 11. Okay, so like ideally I want you guys to be able to do these by yourselves, but if you need to sort of watch me and then do it, or you could pause as I'm working through it. Domain is your x, range is your y. And I'm going to end with xer for my domain, and y belongs to the set of real numbers for my range. I'm going to put x in the center for domain and y for range. This is where I want you to pause this. I want you to look at this circle and see if you could figure out what is your biggest and your smallest x values. What is your biggest and your smallest y values? Okay, so pause that and then check my answer. Biggest x value is 2. Smallest x value is -2. That would be your domain. For your range, biggest y value is 5. Smallest is 1. That would be your range. Let's look at that triangle. So again, you guys set it up with me, and then you pause it and see if you could do this. So domain and range. X is such that, Y is such that. So it gets pretty repetitive. And we're always going to end with YER. Oh, YER would be here. See, if I was in class, you guys would be like, nope, Mrs. King, XER goes there. Okay, domain. X goes in the center. Range, Y goes in the center. What is your biggest and your smallest x value? So this is where I want you to pause it. Find your biggest and your smallest x. Find your biggest and your smallest y. Biggest x, you should have said 3. Smallest x, -3. Biggest y is 4. Smallest y value, -2. That would be your domain and your range. Going back here, let's see if there's one that I want you to do for your homework, this guy. So before you come and watch the next part, let's see how far we, and actually I'll keep going. Before you watch the next part, I want you to try this one. Okay, going back to your worksheet now, I realize that there's a domain and a range that I need to show you, and that's going to have open dots. So I'm going to explain to you what an open dot versus a closed dot is. So we're going to actually do number 2 together, and we're going to do number 9 together. So for number 2, if I said, okay, what's your domain? So pretend right now that there's no dots that are opened, or like just pretend that that open dot is not there. How you'd set up your domain is x is such that you'd end it with xer, and in the center you would put your x and your inequality signs. These inequality signs, you guys, will never ever flip. When you have a biggest and a smallest x value, your inequality signs will always be in this direction. So never ever flip them when you have a biggest and a smallest x value. Okay, super important. Okay, so we'd normally do the same thing and we'd say, what's my biggest x value? What's my smallest x value? So on my graph, my biggest x value is at 5 and my smallest x value is at -5. Now I need to talk about what an open dot versus a closed dot means. This x value on the right um, is closed. What that means is my graph actually touches 5. It comes all the way down and it actually touches 5. So x, if it's a closed dot, it's equal to 5. It's less than or equal to 5. This open dot, what that means is my graph is going to approach -5, but it doesn't actually touch it, right? If it was a closed dot, it would touch -5 right there, but this open dot means it doesn't actually touch -5. So what I need to do, because it doesn't touch -5, my graph approaches -5, so that means it could be like -4.9, but it doesn't actually equal -5. I have to go to my inequality sign and I have to get rid of that equal to. So my domain is x is less than or equal to 5. Here it could be 5. But when I read it this way, x is greater than -5. It's not equal to -5. It doesn't actually touch -5. If I was to do my range for this one, I would say is probably the most tricky. Y is such that, comma, y-er, and I'm going to put my y in the center. Okay, let's first do our biggest and our smallest y values, right? So pretend that both dots are closed right now. You would tell me that your biggest y value on your graph is 2, and your smallest y value is -2. Now we have to figure out, are we going to delete or erase near this negative, this inequality, the equal to? So if my graph was over here, I would say at this point, yeah, it's not actually touching -2, it's approaching -2. So this side would make me want to erase this. However, if I go to this dot here, you have to ask yourself, does that actually touch -2? And this one does, right? It actually touches -2. So I will keep my equal to because my smallest y value is actually -2. On this side, it would be like -1.9, but on this side, it's -2. So my range would just stay as is. Let's look at one more example with these closed versus open dots, which would be number 9. So let's do number 9 together. Okay, set it up the way we normally set it up. X is such that, Y is such that, XER, YER, and I'm going to put X in the center, and I'm going to put Y in the center. Okay, what is your biggest and your smallest X value? Biggest X value is 3. Smallest X value is -4. Now I have to look, do I erase any equal to signs? So I have an open dot here. And what does that mean? It means that my graph approaches 3, but it doesn't actually touch 3. So it maybe gets to 2.9, 2.99, but it doesn't actually hit 3. So I would erase my equal to sign on that side. So x is less than 3, x is greater than or equal to -4. Let's look at the range. For the range, my biggest y value is 5. My smallest y value is -5. Now I've got to figure out, do I erase any dots or any equal to signs? Okay, this 5 here is an open dot. So what does that mean? Can my biggest y value be 5? No. It approaches 5, but it doesn't actually touch 5. So y is less than 5. Down here, I have another open dot. Could my y value, does it touch -5? And the answer is no, it doesn't. It approaches -5, but it doesn't actually touch -5. So I would erase my equal to for both of those. Okay, the last type of inequality, or sorry, not inequality, the last type of domain and range. So now go back to your workbook, and we're going to do a class example, I believe it was 2C. And we're going to see how 2C is different. For 2C, we have arrows, okay? And if I said to you, okay, we're going to do the domain for 2C. So let's set it up. X is such that range y is such that. Whenever you have arrows, if I said to you guys, what is your biggest X value? What you have to realize is that this guy goes forever in that direction. This graph goes forever in this direction. Well, what would your biggest X value be if it just keeps going on and on and on? Your biggest X value is infinity. Your smallest X value is negative infinity. Now, when we do domain and range, we don't actually show the infinity sign. So how do I write my domain and range without showing the infinity sign? And that would be, how we would say that is because our domain goes from negative infinity to infinity, we just simply write XER. And that would be our domain. And what you're saying is X belongs to the set of real numbers. The real numbers means X could be any number from negative infinity to infinity. Okay? I'll show you another one of these in the next example. Now, if I said the range, this graph does have either a biggest or smallest y value. So the biggest y value on this graph would be this guy here at 4. If I said, what's the smallest y value? If this just goes forever down and down and down, the smallest y value is negative infinity. So remember that I said when we're doing our domain and range, we don't want to use infinity when we're writing out our domain and range. So how do we write our domain and range when we only have one number? Because we're dealing with range, we're going to write y, and we're either going to, when we have one number, write y is greater than or equal to 4, or y is less than or equal to 4. So what you have to ask yourself, are the y values on your graph bigger than 4 or less than 4? If this is 4, is your graph bigger than 4 or less than 4? Your graph is less than 4. So, and here's an example. Here's a point on my graph. What's that y value? That y value is 1, which is less than 4. So how we would state that is y is less than or equal to 4, comma y er. And you'd close that bracket. So again, this one I would consider to be the most challenging to wrap your head around, but let's look at some other examples. So flip your page and let's look at class example 3. If I said, write the domain of this guy, I really need you to exaggerate this. This is going to go forever and ever in that direction and forever and ever in this direction. What's your biggest X value if this graph just keeps opening up and up and up and up? You'd say infinity. What's your smallest X value? Negative infinity. So your domain, because we don't say infinity in our domain, we would say X is such that, how do you tell me that it's going from negative infinity to infinity, that it's any number? XER. That's how you tell me that. For the range, Y is such that. Okay, this graph does have either smallest or biggest Y value. Are you able to look at this graph and tell me what that would be? So if I said, well, what's your biggest Y value? You'd say, well, it keeps going up infinity. What's your smallest Y value? Negative 3. How do we do domain or range when we have an infinity sign and a number? We don't use the infinity sign, so we're going to use this number. And because we're dealing with range, we're going to write Y. Our graph is either greater than or equal to negative 3 or less than or equal to negative 3. So if this is negative 3, what is your graph? Are your y values bigger than, which would be that direction, or less than, which would be that direction? Our y values are greater than or equal to negative 3, because this y value here, you guys, is 2. That's numbers bigger than negative 3, comma y-er. Okay? To do some more examples on domain and range. Let's look at class example 8. So if I said, what's the domain of class example 8? And again, if this was in class, I'd say, okay, you guys, I really need you to exaggerate this. So this graph is really going to go forever in to the right and forever, it's going to go up and to the left forever. So what's your biggest x value? Infinity. What's your smallest x value? Negative infinity. What would the domain, how do you state that when you go from negative infinity to infinity? X belongs to the set of real numbers. Range. What's your biggest and your smallest y value? Okay, your biggest y value is infinity. Your smallest y value is 0. Whenever we have a number in infinity, we're only going to use the number. And we're going to say, because we're dealing with range, y is such that. Is my graph less than 0 or is my graph greater than 0, right? If this line is 0, this is above 0, this is below 0. My graph is greater than 0. So we'd say y is greater than or equal to 0, comma, yer. This guy, let's say I said you do the domain and range of this guy. You would say, okay, domain, range. My biggest x value is 4. What is your smallest x value? If this continues forever, it's negative infinity. So my range would, no, sorry, my domain, would it be x is greater than or equal to 4 or x is less than or equal to 4? So remember, we're dealing with our x values. This is 4 this time. Is your graph less than 4, which would be this direction, or greater than 4, which would be that direction? And my graph is less than 4. So x is less than or equal to 4, comma, xer. Let's see if we could figure out the range. This graph does have a smallest y value. Now, if I exaggerate this, right, so this graph is going to continue forever to the left, and it's going to go slowly and slowly creep up, 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 up. So if I say, what's your biggest y value? Infinity. What's your smallest y value? Would be that guy there, which is 0. So again, we have one number, and we have infinity. So we have another number and we have infinity. And we have to say to ourselves is, because we're dealing with range, is my graph bigger than or equal to 0? Or is my graph less than or equal to 0? So this is 0, right? Because we're dealing with range. And this is greater than 0, this is less than 0. My y values on my graph are greater than 0. Close that guy. Last question we'll do is question 3. So question 3, again, I'd say please exaggerate this. So what you should be seeing is, yes, this graph continues up and to the right forever. So the biggest x value is infinity, and the smallest x value is negative infinity, right? So the domain of this would be x is such that x belongs to the set of real numbers. Then, if I said, what's your biggest y value? Well, my biggest y value, again, is infinity. And my smallest y value, it just keeps going down, 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 is negative infinity. So how do we do range when we go negative infinity to infinity? Y is such that y belongs to the set of real numbers. Okay. Let me just quickly go back to the workbook and let me make sure we're done all these questions. So we don't have to do class example 4 or 5. I just really want you to have a good understanding of how we write domain and range. So I want you to do question 1. You should have done 2A and D. Now you could do C. One thing I'll show you with C is we have to figure out if this is 20, what do they want one hatch mark to represent? So remember how we did this, I showed you in the last podcast, is you say to yourself, how many hatch marks do you count from 0 to get to 20? So 1, 2, 3, 4, 5. So 20 divided by 5 is 4. What that means is each hatch mark is worth 4. So that guy would be 4, 8, 12, 16, and 20. This would be -4, -8. So when I say what's your smallest x value, -8. What's your biggest x value would be infinity. What's your smallest y value would be 4, and your biggest y value would be infinity. So see if you could do C. And for B, what's your biggest x value? Infinity. Smallest x value? -infinity. What's your biggest y value? So now y, infinity. Smallest y value, if it goes forever, -infinity. So how do you write that? When your domain is from -infinity to infinity and your range is from um, -infinity to infinity. Remember, just x-e-r, y-e-r. The last thing after you're done those questions is you have a worksheet now that I want you to do, and I'll upload this worksheet with the solutions. Cross out this question, so cross out question number 1 and cross out question number 4. You don't have to do those. Do every other question, domain and range. Is it a function? I'll show you in the next podcast what a function is. So don't worry about is it a function for now. It's super easy to tell if it's a function. And one thing that you'll notice is these are the exact questions that I've sort of already podcasted. So now I just want to see if on a separate worksheet, are you able to redo these? Because if you're able to do these questions, I could throw any domain and range question at you and you will get it right. And that concludes the lesson on domain and range.